Zeros of a function, those are the values of x that give us y equals 0. All right. The zero of a function is the number that you would plug in to make the answer 0. Okay. So what number would you plug into this in order to make the y value 0? The x values that make y 0. That sounds kind of like something I've already talked about. The x values that make y 0. When did I talk about that earlier?
X-intercepts.
X-intercepts, yeah. Because zeros and x-intercepts are very closely related. They're almost the same thing. Okay? There's a connection there between those things. And so if I asked you what the zeros of this are, okay, well, we would just say the zeros are, well, if x equals -4, then the y value is 0. If x equaled 2, the y value would be 0. And we see that because the coordinates of that point, -4, 0. Plug in -4, we get 0 back out. And we plug in 2, we get 0 back out. So these two things are very closely related. Yeah. This is, again, something that I'm going to push you guys towards knowing better. There's actually 4 terms that are related like this. So x-intercepts and zeros being the first 2. The next one being solutions, and then the last one being roots. Really, those 4 things all mean pretty much the same thing. Okay, and why I want you guys to know that is because basically means I could ask you almost the same question, but in 4 different ways, and expect you guys to be able to, kind of realize what to do. If I said, "Hey, solve this equation," right? You kind of get an idea what that means, like how to solve equations. You've been working with that for a while. But if I said, "Hey, find the zeros of this equation," maybe that gets a little tricky. You're like not sure how to find zeros. Like, what's that mean? That sounds different. But if you realize that zeros and solutions are really the same thing, that, oh, well, he's just really asking me to solve it. Okay, I can solve this equation, right? It can kind of be one of those things. Or if I said, "Hey, here are my x-intercepts. What are the solutions to this?" Or if I give you a graph, and if I give you this graph and I say, "What are the solutions to this equation?" Like, how do I solve this without without the equation if all I have is a graph? If I realize that solutions and x-intercepts are the same thing, then I just know my solutions are -4 and 2. And so, again, that's something I'm going to push you guys towards. It's not. This is kind of the first time I'm going to say it to you. You're going to hear me say it a lot. 4 things: x-intercepts, zeros, solutions, and roots really mean the same thing. They're pretty much the same thing. Okay, and we're going to work towards knowing that. All right. Rate of change. This was something that was on the second worksheet, and a lot of you struggled with that. But rate of change is really just the same thing as slope. Now I want you guys to notice that they're asking us for a rate of change like within a certain interval. Okay. So between those two numbers, so if I go over and look at the graph, so they want the rate of change in this space. Okay. Well, when we think rate of change, when we think slope, what 2 words should be popping into our head? Rise over run, right, Audrey? Okay. So if you start on that left side, just like we always do. Okay. Start on that left side. So at that first point, there's -4. All right. And then we go to -1. Okay. Well, what's my rise? What's my run? Okay. So in order to rise, I'd actually have to fall down 3. And then I'd have to run 3. Okay. So -3 over 3. Which of course is -1. Yeah. Somebody in first hour asked, couldn't we have just, gone down one and over one, and then we end up on another point? Which is true, but it's only true for a problem like this, where that side of the graph is a line. Okay. If that side of the graph had been anything but a line, it wouldn't have worked. So like if I was gonna ask you that same type of question on a curve, then that idea wouldn't work. So it's not a good idea if it only works sometimes. So if I had a curve that was like this, and I said, hey, let's find the rate of change between -4 and -1, right? There's no way for me to, well, there's a way, but like if I found, okay, the rate of change there, but then I find the rate of change here. If you remember from that second worksheet that those rates of change kept changing, so that would happen the same way. I know I'm not drawing it very well, but these little fractions here would be different from each other, and that's not what we're asking right now. What we're asking is what's the overall rate of change between this point and this point. And so you just want to do a straight drop and run. Don't try to do little steps. This just doesn't work. Okay. We always go from left to right. So I'm going to start here and then go in this direction. So if I said, let's find the rate of change between 0 and 5, okay? So then I would start where x is 0, and then I'd see where x is 5. I'd start on that left side, move towards the right side. So that means I'd have to rise to get up first, right? Rise first and then run. Okay, and then I'd have to see what the rate of change on that. Okay, so yeah, always go from left to right. Keep saying that a lot about different things, right? Domain, the intervals, it's always left to right, left to right, left to right. Thankfully, that doesn't change for the slope stuff either. So yeah, good question. Thank you for asking that. Okay, so you guys are gonna have graphs for these. You don't need a slope formula. Okay, you're just counting on the graph. It shouldn't be a big deal to find rate of change. Okay, so. Anything about rate of change you guys want to talk about? Thanks, Jared. All right, so here we're getting to the new stuff, right? Stuff I just introduced you guys on Tuesday: positive, negative, decreasing, increasing. Okay, so I'm going to define that for you guys again. We're going to do the example here. So what it's asking us, right? Where are the what are the intervals where the graph is positive? So what does it mean for a graph to be positive or for a function to be positive? It's the x values where the graph is above the x-axis, or a different way of saying it, what x values give us positive y values, positive y answers. Okay, so just two ways of phrasing that question. So 3 ways of phrasing that question, right? Intervals where the graph is positive. How do I read that? How do I make sense of that? Okay, it wants to know where the graph is above the x-axis, or it wants to know what the x values are that give me positive y values back out. Right? So 3 different ways of saying that question. You got to figure out the way that works for you. Can you read the first one, the one that's typed there, and make sense of that? Or do you need to have something in your head that's saying, okay, this is what this means, right? And then that's something you need to do for yourself. Okay. And so if I look at the graph, right, where is it above the x-axis, right? That's a really visual thing, right? So I notice here there's a space where it's above the x-axis, or over here it's above the x-axis. Okay. and we want to write an interval. Right? So we're thinking interval notation, parentheses, brackets, things like that. Okay. One of the weird things about all four of these things we're about to do, we're talking about up and down, right? Above, below, increasing, decreasing. Those are like up and down words, right? But we have to write left to right. We have to write about our x's. We're looking at our y's. We're thinking about our y's, but we have to talk and write about our x's. So your brain's going to struggle with this a little bit. Okay. So look back at the second way I phrased that question. What x values? The question is asking you about x. You better be speaking about x. Now you're looking up and down, but you're talking left to right. So it's tricky. Okay. So just like the domain, I'm going to look at that left end of that graph. What do we see there? Jared, it kind of looks like you're talking, but I can't hear you. I'm asking what do we see at the left end of the graph, Audrey? That left side of that positive space. What do we see? Jared, if you're talking, you're still muted, dude. Yeah, there's an infinite arrow, right? So that space all the way to the left is positive, right? Where does it stop being positive?
It stops being positive at -4.
Yeah, -4.
0.
So from all the way to the left, which is our negative infinity, to -4, the graph is positive, but it stops at -4. Okay, so from negative infinity to -4, that's where the graph, that's one of the intervals where it's positive. Okay, any of those numbers, if I plugged in any of those numbers, like -5, -10, -3,000, it would give me a positive answer. That's really what this is saying. Okay. What's the value at -4? What's the y value at -4? It's not -1, Audrey.
0.
It's 0. All right, when I plug in -4, I got 0, right? I said that earlier, that's the x-intercept. Is 0 a positive number?
It's neither.
It's neither, right?
Just 0.
So we can't include it in our positive interval. So what's our symbol that says we're not including that number? We're just going to get close to it.
Is it the curly braces?
It's the parenthesis, or it's bracket versus parenthesis when we're doing interval notation. So parenthesis on the 4 because we can't include -4 because it gives us 0, not a positive number. Of course, infinity is always going to parenthesis. Yeah. So a lot of times I'm so far as this year I've been seeing students struggle with that because like it stops right at -4. So they want to put a bracket on the -4. -4 does not give us a positive answer, so we cannot include it in the group of answers. But remember what this says, okay? We have no way of writing the number we mean by this. Okay? What this means is the number that's right next to 4, -4, which would be -4.000000001, right? An infinite number of zeros. We have no way of writing it. Okay? So we have to have these symbols to mean that. This means the number that's as close as possible to -4. Okay? So since we can't physically write it, we have to use these symbols to stand in its place. But -4 is not an exact value. Okay? I know that's a little weird. Okay? Then we go to the other positive interval. Where does that other positive interval start?
It starts at 2.
Starts at 2. And then where does it end? Where does it stop being positive?
Positive and
Yeah. Well, so by that, Jared, it means it doesn't stop being positive, right? It stays positive forever after that, right?
yeah.
What's the value of y at 2?
0.
0. So can we include 2? No. So again, 2 gets a parenthesis. Because 2 gives us 0. 0 is not positive, so we're just going to be that number right next to 2. So 2.000000001. Right? And again, we can't write that out, so we have to have these symbols to say that. So here are the intervals, here are the spaces where the graph is positive. Here are the numbers I could put in to get a positive answer back out. Right? I could plug in -10 and it would give me a positive answer. I could plug in -1000 and it would give me a positive answer. I could plug in 2.5 and it would give me a positive answer. I could plug in 13 and it would give me a positive answer. Okay, so that's what we're after here. What numbers would give us positive answers? Okay, and there's 2 sets of numbers that would do that. So we have to write both intervals. So then the flip side of that, what's it mean for a graph to be negative? So if you want to write that down, you can. You would say the x values where the graph is below the x-axis, or what x values give us negative y values. So you would just switch these 2 words to be below and negative if you want to write kind of definitions of that question for yourself. Switch that to say below, switch that to say negative. Okay, if one of those makes more sense to you, then switch that one. Okay, I'm not going to write it again. So where is it below the x-axis, right? So we see that portion of the graph that's below the x-axis. Well, where does that portion start? Where does that piece start? Where does that chunk start? Where does that interval start?
-4.
-4, okay. And where does that interval end?
2.
2. Right. Can we include -4 and 2? Can they be brackets or should they be parentheses?
They should be parentheses
Why is that?
because you run through them. You don't actually stop at them.
Mm-hmm.
It involves 0.
Involves 0, right? The value at -4 is 0. The value at 2 is 0. 0 is not negative. So we can't include those values. But again, we want to be the number right next to -4. But this time on the right side of -4, which would be -3.99999. That'd be my first number. And then my very last number would be the number right next to 2, which would be 1.99999. Okay? So we're saying all of those numbers between -4 and 2, but we can't use -4 and 2. They're left out. So a number like -3 would be fine. A number like -0.2 would be fine. A number like 1.7 would be fine. Okay, those would give us negative answers. Okay, so when you're doing stuff like this with positive and negative, we shouldn't have brackets. Like 99% of the time, you shouldn't have brackets. Okay, because that number is always going to be that endpoint where it switches from positive to negative is 0, and 0 doesn't get included. Okay, there are very strange little situations where we could end up having a bracket. We won't see those very often. When we do, I'll kind of warn you about that. Okay, but for the most part, you shouldn't have brackets here. And notice, look, -4, -4, 2, 2. Like there's a reason these numbers show up twice, because that's that changing point, right? That's that x-intercept. Okay, so there's a relationship here. That's not a coincidence. Okay. Then looking at increasing, decreasing. All right. So I want you guys all to do this. If you have it printed out, I want you to take your finger or your pencil and physically put your finger or your pencil on that left end of that graph. If you're doing this on the computer, I want you to take your finger, or if you don't want to get your screen dirty, get a pencil or a pen like with a cap on it so you're not scratching your screen, and I want you to physically touch your computer screen on that left end of that graph. Okay. So you're touching the same place I am, but you get to see my little arrow. Okay, but I want your finger on it. I want you to make that physical connection with this. This is going to help your brains. Okay, we're going to follow the path of our graph, just like we always do, from left to right. Okay, so if I want to go right, I'm not just going to shoot off the path. Okay, I'm going to follow the path. What else am I being forced to do as I move right? Because I'm following the path of the graph. What else am I being forced to do?
Decrease.
Decrease, right? So this portion of the graph is decreasing, right? And then all of a sudden it turns and it starts, as I keep trying to move right, it's increasing, right? So we have a portion of the graph that's decreasing. We have a portion of the graph that's increasing. We have an interval that's increasing. We have an interval that's decreasing. Okay, a graph can increase and decrease. Okay, we talked yesterday about lines increasing and decreasing. We said, no, that's not possible because lines are straight. But this is an angle, right? So we have a piece that's decreasing. Oops. And we have a piece that's increasing. Okay. But a lot of times we look at a graph like this and we see those two arrows pointing up and we're like, oh, always increasing, right? Which is not the way we're supposed to look at it. As you move from left to right, it decreases and then starts increasing. Okay. So how do we describe that interval? We always start on the left end. So that left end of our graph, where is it pointing? Where does it stop? Circle's getting awfully weird. What's going on here, guys?
It goes to infinity, so
Okay.
I have to start there.
Okay. So what am I going to write then?
And
Yeah, I heard you say infinity. But which direction is that pointing? Right, Audrey? It's pointing to the left, so it's
so
negative.
infinity.
Okay, it's not that it's pointing up, right? We're talking about x stuff. It's pointing to the left, which is negative infinity. Okay, it's a common mistake because people you focus on that upness because we're talking about increasing, decreasing. It's the leftness of that arrow that we're really concerned about. And left, infinities always get parentheses. Where did it stop in decreasing? What value did it stop decreasing at?
-1.
What was the first thing I heard? -3, -1. So which one should we be talking about, Audrey? And then see Audrey what typed in the chat there. She typed -1, -3. Which value should we be worrying about right now? Is it the -1 or is it the -3? We should be thinking about the left to right values, the x values, right? Again, that's what's going to make this tricky. Okay? It's actually the -1 I'm concerned about, Kenzie. Okay. So I want to know the x's that are making the y's drop. Okay, that's a -1. Okay? So that's hard because you're looking up and down, but you have to write left to right. It's tricky. Okay. Again, we do not include that turning point in our answer. So there's going to be no bracket. And then at -1, it flipped directions on us, right? Turned and started heading up. And then it started heading up forever as we move to the right. So I guess when I write that positive infinity there, I'm not talking about positive infinity up. I'm talking about positive infinity right. These are x values. I'm talking about these are x values. These are x values. These are x values. Everything here is an x value. We never refer to this stuff in y values. You will never ever do that. Okay. It's always looking up and down, but writing left to right. Looking up and down, but writing left to right. Okay. We're talking about the x values that make the y values do certain things. Okay. So just notice here, none of this stuff has brackets on it. those changing points don't get included. Okay. Again, there is very small, very particular instances where there will be a bracket, but they're strange things. And like 99% of the time, there will not be a bracket on this stuff. Okay. I want to flip to the other side and do a couple of examples with you guys, but there's nothing new. This is like what I wanted to teach you guys today, and we're just going to practice a little bit. And then the homework's the exact same thing as this stuff. Is there anything that's like really not clear for you guys right now? Okay. So normally, if like if we were together and people in person, I'd have you guys like get in groups and like work on doing this together. But and we just don't have the time right now to do that. But let's go ahead and work through this together. So we got our graph over here to the right. Want to find the y-intercept, the x-intercepts, the zeros, the domain range, like rate of change. Like all these questions here were the ones we were just answering on the other side. What was that, Audrey?
I might have been looking, but can you just show me the answer that you put for when the graph was increasing so I can double check?
Sure. It was -1 to infinity.
Always gonna be flipped like that.
Yeah, pretty much for what we're doing right now. Like, cause that's the point where it stopped, right? That's the point where it turned. Yeah. There's always some like there are graphs that have like gaps in them. We aren't really going to get into that. So yeah, it's
just not
again not always, but for what we're doing, I think it's a pretty good rule of thumb. What was that?
It's just not negative infinity because we're talking about the graph that's increasing.
No, it's not negative infinity because it's heading to the right. We're saying that from -1 and then to the right forever it increases. So that right being a positive. Here, this is, that's not talking about going down. This is talking about from the left side forever, right? All of those numbers all the way to the left, and then it's stopping at -1.
See.
Yeah. Okay. So yeah, it's again that idea that you're thinking about moving up and down, but you're talking about moving left to right. It's tricky. So what are the x values that make the graph move down? What are the x values that make the graph move up? Okay, that's what we're really saying. All right, the question's about the x values. So we have to talk about the x values. So yeah, it's tricky. Okay. So what's our intercept? That should be easy. Come on, let's go. Yeah. Y-intercept.
Would it be 0 and -1? Or I mean
0, +1.
0, +1. Is that what you're trying to say, Kenzie?
Yeah, that's what I was trying.
Okay, so 0, +1. Or you could say y equals 1. But yeah, I actually really like that you're saying 0, +1, because that's going to help you cement that idea that we need the 0, right? That x being 0 is important. Okay, so but both of those are acceptable. But again, I prefer you guys probably just say 0, 1, just to help you learn that. Thank you, Kenzie. Thanks. Addison, what about x-intercepts?
Wouldn't it be the 1?
1.
And before, I mean.
Say that again, sorry.
-4, and then I don't know.
Is it hitting the x-axis at -4?
it's hitting it at -3.
Okay. Where else is it hitting?
At +4.
Where else?
+4.
Where else?
-1.
-1. Okay, so this one has 3 x-intercepts. So you could say, yes, no.
I have 15 minutes left.
You can have 5.
Okay.
Okay, so you write like that. Oh, it's not -4, sorry. Trying to write and talk to her. Or again, I think probably a little better if you say it's -3, 0, -1, 0, 4, 0. Okay. So those x-intercepts, points which crossing the x-axis. So then what are our zeros?
Your zeros would be -3, -1, and 4, right?
Correct. How'd you know that, Aiden?
Those are all the x-intercepts, and that's also where the y-axis equals 1 or equals 0, not 1.
Okay. Where the y coordinates are equal to 0, yeah. So what x values give us 0 for y, right? And these things are connected. Okay. Good catch there. June, what about the domain? And then while we're waiting, Jake, I'm going to ask you about the range. And Samantha, I'm going to ask you about the rate of change. Little warning. So June, this is a continuous graph. So we should be writing this in interval notation. So what you kind of typed out there would be if this was a series of dots. And if I only had discrete points, like if I had a point, but not the line connecting them, that would be okay to list numbers for a range or domain. So we can't do that for a continuous. We need to write in interval notation. So what direction should you be thinking for domain?
7th hour starts in 3 minutes.
It sure does, yeah. I'm on. Starts in 3 minutes, or this class ends in 3 minutes?
This class already ended.
I'm bad. I'm sorry. I thought I ended at 26.
Nah, that's when 7th hour starts.
Okay, I have some apologies. Okay.
I wish we had more time, but we don't.
Thanks, Audrey. Okay, my bad.
Yeah, sorry about that. My computer died.
Poop. Okay. Let me just write that down real quick. I've been recording this, so I'll just, once you guys peace out, I'll talk through the rest of it and then post the video. And then I'll also post my written down notes so you guys can see those. But so yeah, you guys get go. The homework is this.
I think you explained it enough, but
okay. Yeah. This is the homework.
Pick up on it next class.
I would hope so. We'll see. This is your homework, right? Again, that second thing that came in your email, it's the second thing that's attached to the Google class. It's all the things we were just doing. There's nothing new there. Okay. So just practicing that. Okay. Yeah, sorry for keeping you guys late. I need to switch that in my head because I've been thinking that for days. But yeah, the domain would be from -4 to 4. And then the open circle here on the domain would give us a parenthesis on the left end. And the closed circle there on the domain would give us a bracket on the right end. And then range, we should be thinking the low to the high. So the lowest value on the range is -1. The highest value we see there is at 3. And remember, you have to assume that it's hitting those points since it's not telling us otherwise, so that gets a bracket. Assume that it's hitting there, so that gets a bracket. What's up, Noel?
Can I have a cookie?
You sure can.
Thanks, Dad.
And then rate of change between -1 and 2. So here's my x value of -1. Here's my x value of 2. I'm looking at that part and saying, well, how's things changing there? Always starting on the left side.
Can we?
Yep, I said that already. I said I was just going to keep talking through this so I could post the video. So I'm going to rise 3. And I also have to run 3. Oh, 3 over 3. This one. And then where's the graph positive? So that's the parts where it's above the x-axis. Oops. So we have a couple intervals where it's positive. Looking at that left side, like always. So that x value there is -4. And that's the open circle on the -4. So that's going to be that parenthesis. Where does it stop being positive? It stops being positive at -3. We never include that switch point. So that's not going to be bracket. It starts being positive again at 1. Or sorry, -1. I'm not going to include that, so it's going to get parenthesis. And then keeps being positive until 4 again. Even though that's a closed dot, we never include that value because that value is 0, or gives us 0. So it's still a parenthesis. So just kind of that rule of thumb that those endpoints on these positive negatives don't get included. Where is it negative? Just in this space. This little interval here, where it's below the x-axis. So where does that start? It starts at -3. It ends at -1. Right, those numbers right here. See those again, just like we did on the other side. So from -3 to -1, those those numbers would spit out negative answers. Again, don't include them. Always get parentheses. And then increasing, decreasing. So if you remember when I was telling you guys earlier, it's like put your finger on that left end of the graph, right? And start there. What are you doing? So I'm being forced to go down, and then it goes up, and then it goes down again. So I actually have 2 intervals of decreasing, which I don't think we've seen yet. So there are 2 places where the graph goes down. So just like before, start at the left, move to the right, where but make sure you focus on the x value, not that y value. So what's the x value there? So x value, x value. So from -4 to -2, we don't include the switch points. And where does it start being decreasing again? It starts at 2, ends at 4. Oh. So there's the parts where it's decreasing. And where is it increasing? So between those 2, right? So starts increasing at -2, stops decreasing at +2. Notice I'm not looking at the y values. I don't care how high it goes, I'm caring where that's happening. So between these 2 numbers, it's going up. So from -2 to +2, it's increasing. We do not include those endpoints. Again, look how this is connected, right? -2, -2, 2, 2. So it connects there. So hopefully that helped.